Hello everybody and welcome to the 5th week of development on Project Younger Dryas, a turn-based strategy game about restarting civilization by teaching technology to surviving hunter-gatherers after a world-ending cataclysm. This week was, to be honest, quite difficult and a massive headache. I had planned to work on the pathfinding for hunter-gatherers and wild animals and get some movement bugs fixed. How I had imagined the pathfinding to work was that the hunter-gatherers would have two basic needs, food and water. This need would deplete by a certain amount every turn, and the tribe would seek to satisfy whichever need was lower than the other at the moment. This would usually mean that they would be moving between rivers and forests, which is a gross oversimplification of actual hunter-gatherer activity, but I thought it would work for this prototype and for the purpose of this game. The problem arose in the implementation. I looked for A-star pathfinding implementations for Unity and found a pretty good pathfinding class on a Unity answers page, so I didn't need to write one from scratch myself. Here was my proposed algorithm at the time. Hunter-gatherer is hungry, so food is less than water. Hunter-gatherer looks for the nearest food source. Hunter-gatherer checks if a path can be formed to that food source. If yes, a path is made and stored. If not, then it looks for the next closest forest until one is found and is pathable. Now, this seems relatively simple at face value, but I forgot one of the golden rules of programming, problem solving, and project management. Break down larger problems into smaller ones until you can much more easily solve those smaller problems. The problem in that first algorithm was the second step. Hunter-gatherer looks for the nearest food source. This is not as simple as just that. It requires an algorithm to do that, and in the planning phase, I didn't take the time to figure out what that would be. To understand why it was a problem, I need to explain the way in which I have set up my tile maps at the moment. So in Unity tile maps, every tile is visually represented on the screen with the class tile base. There are several layers of tiles so that they can be overlaid on top of each other and differentiated based on their purpose. Think of these layers as being similar to those in Photoshop or GIMP. While Unity offers a visual representation of these tiles and tools to modify them visually, it does not, however, offer a logical implementation of this in the code. Well, as far as I know. So my implementation was, and I'm pretty sure I read something like this on Unity Answers as I was doing my research, but my implementation was to have several lists, or technically dictionaries in C# terms, which store an instance in a small class that would represent that tile type. So for example, I would have a class in C# called tile, which stored basic data that would be common to all tiles, such as tile position, its index in the list, its location in the world, whether one can traverse it, etc. Then I would have specific tiles such as a forest tile, which would inherit from that base tile, and I would add in a couple of other variables like resource type that this forest tile is supposed to represent. Basically, these lists would map a location in the tile grid to an instance of a tile class, which could be expanded further to store more specific detail. This made getting tile properties based on their location easier from dictionaries. It also meant that I don't have to store an array of every tile location to a tile type, and only those that actually exist on the map. I can imagine that it isn't the most optimal or best implementation, but at this stage in development, just getting things working is more important than optimization. The problem with this implementation was that in order to get the location of a specific tile within a radius, I would have to iterate through every single tile in the dictionary of that tile's type and check whether a path existed to it, and then check whether it was in range. So just to get a tile within, say, a 2-block radius, I was iterating through all of the tiles of that type on the map and then checking whether they were in the radius, and I was also checking whether there was a path to them. So every time I iterated through the list and checked these things, I would also invoke the pathfinding, and therefore there would be a call to the pathfinding function, which is a relatively expensive one. This was extremely inefficient to say the least, and every single turn took ages and froze up because of this iteration. So I looked for a method to not have to reiterate through every tile and get the tile I wanted within a radius. After some research, I came across the flood fill algorithm. In principle, it essentially replicates how water flows and fills up gaps that it has access to. So I don't have to iterate through every single tile of the map. I can just get the neighbors and check whether any of them within a certain range is the tile I want. It is still quite expensive, but not nearly as expensive as going through every tile on the map. So for now, this is my current implementation and seems to be working well. Throughout the process, it was also frustrating to have Unity freeze up every time I accidentally implemented an infinite do while loop, which actually happened quite often. The way I tend to code is to write out an implementation and see if it works. And so this meant that I was mostly waiting for Unity to respond or restart it. This became really frustrating really quickly and led to a lot of procrastination. Honestly, it was my fault. So maybe I should write code that I've actually thought about before implementing it. So this week, I mostly learned a lot of things about tile maps and searching algorithms and the like, plus a valuable lesson in breaking down problems further than I sometimes do. Next week, I plan to fix some bugs in the movement and clean up the code a bit, and also implement the wild animals that would have similar needs to the hunter-gatherers, such as food and water, and the interesting interactions between these two when they meet each other in their quest for the same resources. If you have gotten value out of these devlogs and want to keep up with development on Project Younger Dryas, please consider subscribing to this channel. If you enjoy this sort of content, then please leave a comment and a like, it really helps a lot. Thanks so much for watching, thanks for giving me your time, and I will see you next week.